Explain ER2 relational mapping algorithm with suitable example. ER2 relational mapping is the process of converting ER diagram into relational tables. Steps in ER2 relational mapping. Strong entity type. Create a relation with all simple attributes. Student, USN, name, branch. ER2 relational mapping. USN is a primary key. Weak entity type. Create a separate relation including the primary key of the owner entity. Dependent of EMP ID, dependent name, age. Primary key is EMP ID and the department name. Weak entity type. This is the dependent entity. Binary 1-to-1 relationship. Add a primary key of one entity as foreign key in another. Person ID, name, passport number. Person ID, name, passport number. 1-to-n relationship. Add primary key of one side as the foreign key in n side. Department dnum, dname. Employee EID, name, dnum. Dnum is the foreign key. Binary m is to n relationship. Creates a new relation containing primary keys of both the entities. M to n. Student USN, name. Course CID, C name. Enroll USN, CID. Primary key is both USN and CID. Multi-valued attribute. Create a separate relation customer has multiple phone numbers. Customer ID, name. Customer phone of customer ID, phone number. Multi-valued attribute. So ER diagram, student, enroll, course. And converted relationships are student USN, name, branch, course CID, C name, enroll USN, CID. Then ER2 relational mapping converts entities, attributes, relationships into relations while preserving constraints and relationship. It forms the basis for database design. Strong entity table, weak entity separate table plus owner key, FK in either table, 1-to-n FK in inside new table, multi-valued attribute separate table. Differentiate between DDL commands and DML commands. Data definition language, data manipulation language. Defines database structure, manipulate the data. Auto commit, requires the commit. Affects schema, affects the records. Create, alter, drop, truncate. Select, insert, update and delete. Create table student, insert into student values. Alter versus update. Alter changes table structure. DDL command modifies the columns, affects the schema. This affects the tuples, changes table data, modifies the records. DML commands changes table data, changes table structure. Alter table student, add phone of varchar of 10. Update student, set branch equals to ISC where USN equals to 101. Delete versus drop versus truncate. Delete, remove selected rows. Truncate, remove all the rows, removes entire table. Drop. Where clause allowed, where not allowed, where not allowed. For delete, where clause is allowed. Then table remains. While truncating also table remains. While dropping, table is deleted completely. Delete can roll back, usually cannot roll back. truncate and drop. Roll back, undo the changes. Removes the selected rows, removes all the rows, removes entire table. Delete from student where USN equals to 101. Truncate table student, drop table student. Next we have DDL is a structure, DML data, manipulation, alter, structural change, update data change, delete, removes rows, removes all the rows, truncate, drop, removes table only. Next, different types of constraints defined during table creation and with the examples. Constraints are the rules enforced on table attributes to maintain data accuracy and integrity. Not null constraint ensures that column cannot have null values. Name varchar of 20 not null. Unique constraint ensures all values in a column are unique. Email varchar of 30 unique. Ensures all values in a column are unique. Primary key constraint uniquely identifies the each record. USN varchar of 10 primary key. Property is unique and cannot be null. Foreign key constraint maintain referential integrity between tables. Deno int foreign key Deno. Foreign key of Deno references department of Deno. Checks constraint restricts values based on the condition. Age int check age greater than or equal to 18. Default constraint assigns a default value if no value is provided. City varchar of 20 default Bangalore. Example table create table student USN varchar of primary key name varchar of 20 not null email varchar of 30 unique age int check age greater than or equals to 18 city varchar of 20 default Bangalore. Constraints such as not null, unique, primary key, foreign key, check, and default help to maintain the correctness and the consistency and integrity of the data in the database. An ER diagram has a multi-valued attribute phone. For customer, explain how it is converted into relational schema. A multi-valued attribute can have more than one value for a single entity. A customer may have multiple phone numbers. ER representation customer of customer ID, name, phone, where phone is multi-valued attribute. While mapping to relational schema, we have two mappings where customer of customer ID, comma, name, customer phone of customer ID, comma, phone number, where primary key is customer ID in customer phone, customer ID, comma, phone number is the primary key, while the customer ID is foreign key from the customer. Here, if it is a multi-valued attribute, we will be considering in the separate table. Customer ID, name, Ram, customer ID, phone number, it is having two attributes. Multi-valued attributes is converted into a separate relation containing the primary key of the original entity and the multi-valued attribute. This avoids redundancy and maintains normalization. Multi-valued attribute is equals to separate table. That is how you should remember. Here the customer ID, comma, name, customer phone, customer ID, comma, phone. Next we have define the terms with example. Super key, a set of one or more attributes that uniquely identifies a tuple. A set of one or more attributes that uniquely identifies a tuple. USN comma name, a set of one or more attributes that uniquely identifies a tuple. It's basically the column names, which is unique. Candidate key, a minimal super key. Candidate key is a minimal super key. That is USN. That is the candidate key. Primary key, candidate key chosen to uniquely identify the tuples. And a minimal super key is tuples, that is USN. Tuple, a row in a relation, is called a tuple. Domain, set of all valid values for an attribute are domain. Domain is a set of all values for an attribute. Branch is an attribute that is having values CSE, ISE, IML, ECE and all. Null represents the missing or unknown value. Phone equals to null. Relational schema. This is a structure of a relation. This is a structure of a relation. Relation state. Current contents of relation at a particular time. Current contents of a relation at a particular time is called the relation state. Relation schema is a structure of the relation. One not one RAM CSE is a current state. An attribute that refers to the primary key of the another relation, that is employee of denom. An attribute that refers to the primary key of another relation is this. Employee of denom, department of denom refers to department of denom. Degree or arity of relation, number of attributes in a relation. Number of attributes in a relation is called degree. Degree is 3. Super key uniquely identifies the tuple. Minimal super key. Selected candidate key. Tuple is row. Domain is valid values. Null missing value. Relation schema is the structure of the table. Relational state is current data. Foreign key references another table. Degree or it is number of columns or attributes. Consider sailors, SID, SName, rating, age, boats, BID, BName, color, reserves, SID, BID, day. Here you can observe SID, BID 2, foreign key in the reserves. Retrieve sailors' names who have reserve red and green boats. Color, okay. Retrieve sailors' name. We have to include only the sailors' names. So, by S name. Who have reserved red and green boats. Sailors, cross, color, where you can choose sailors join, reserves join, sigma color equals to red of boats, because BID should be joined, so that's why we are taking that from reserves. From sailors, which is connected to reserves, then from reserves BID, which is connected to boats. So pi is name of sailors join reserves join sigma color equals to red of boats intersection S name sailors join reserves join sigma, which is a condition, color equals to green of boats. Retrieve sailor's name with age greater than 20 and reserved black boat. Pi s name bracket. Okay, then sigma age greater than 20 of sailors join reserves join sigma color equals to black boats. Retrieves the sailor's name who's reserved green boat on Monday. Pi s name of green boat on Monday. Monday is in which reserves. Sailors pi s name of sailors join sigma day equals to Monday of reserves join sigma color equals to green of boats. Retrieve number of boats not reserved. Count BID. Count BID of boats minus sigma BID of reserves. Retrieve names of sailors who have not reserved any boat. Retrieve number of boats not reserved. Retrieve names of sailors. Pi s name of sailors minus pi s name of sailors join reserves. Retrieve names of sailors who have not reserved any boat is pi s name of sailors minus pi s name of sailors and reserves join reserves. Retrieve sailor name who is the oldest sailor with rating 10. Rating is there in the sailors only, so we don't have to go to join. Pi s name of sigma rating equals to 10 and age equals to max of age of sailors. Find names of sailors who have reserved all boats. Pi SID reserves divided by pi BID of boats, which gives us the intersection of this. Pi SID reserves the all boats, pi BID boats, then join with sailors. Pi S name sailors join pi SID comma BID of reserves divided by BID of boats. Pi S name sailors cross S name sailors join pi SID comma BID reserves divides the pi BID of boats. This is how find the names of sailors who have reserved all the boats. Find names of sailors who reserved the boat 103. Pi is name of sailors join sigma BID equals to 103 of reserves. That's it. Here is the summary of this. If you want to know reserved all boats, then you will be using division symbol. Consider company database, EMP name, SSN, department location, dependent, works on table, project table. Retrieve name, salary of employees who work for research department. pi name comma salary of sigma b name equals to research emp join department who works on the repo, that is b name equals to research of emp join department. Then find names of employees who work on all the projects controlled by department 4, all the projects. So pi name of emp join who work in all projects. Pi ESSN comma Pino works on divided by P number and sigma D num equals to 4 of project. All that is pi ESSN comma P num of works on divided by pi P number of sigma D num equals to 4 project. Retrieve SSN of the employees who are either in department 4 or directly supervise an employee in department 4. Sigma SSN of sigma D num equal 4 of EMP union sigma super SSN of sigma D num equals to 4 of EMP. Then retrieve names of employees who have no dependents. Name or sigma pi name of EMP minus pi name of EMP join dependent. Retrieve each department number of employees and average salary. Group by department number, count SSN, average salary of EMP. Then list names of employees with 2 or more dependents. Group by ESSN, count of department name, dep count of department, sigma dep count is greater than or equal to 2. Join with EMP. Like pi name of EMP join where dep count is greater than or equal to 2. Group by ESSN, count of dep name is dep count of department. Dep count of department. That is assigned to that. Group by ESSN, count dep name as dep count. Count of dep name as dep count of dependent. Then EMP join sigma dep count is greater than or equal to 2. So researchers select plus join, division symbol, union, difference, grouping and grouping count. Suppose a relation has attribute ID comma phone. If multiple phone number exists per person, how would you redesign the schema? Since phone number is multi-valued attribute, it should be moved to a separate relation. Person ID comma phone, person ID, and another is person phone of ID comma phone. Primary key of person equals to ID. Primary key of person phone is equals to ID comma phone. ID acts as a foreign key referring person ID 101, person phone is 101, that multi-valued attributes are represented using a separate relation to eliminate redundancy and maintain normalization.